So a great question to pose now that we've actually been doing examples where we're finding curl and divergence is, how am I supposed to actually interpret the meaning of the curl or the meaning of the divergence? So with that in mind, just as a quick reminder from much earlier in the semester, the curl is defined as being the cross product between two vectors, one being a vector operator and one being our vector field. Now, the interpretation of a cross product way back is that the curl of f is orthogonal to the vector field f. Now, by the definition back then, it's also orthogonal to the del operator, but that has considerably less physical significance. Now, when we consider that two things are orthogonal to each other, so if we do have, a vector in our vector field, the curl would be orthogonal to our vector field f. Now, typically when you have things that are orthogonal in the sense of motion, what you have is a rotation going on. So as the curl pulls us in this direction, it means that it would be rotating our vector from the vector field. So one example of this is in the form of fluid flow. So if you have a fluid that is flowing through a given vector field, particles tend to rotate about an axis defined by the curl of f. Now, with that in mind, that'll help give us an interpretation to when the curl of a vector field is equal to 0. We say that capital F is referred to as irrotational. Irrotational. In other words, there's no whirlpool or eddy at P. So that means that this thing tends not to rotate as it is flowing. Now, one could tell, for example, that if we had a constant vector field, which is pointing at everything in the same direction, the curl would definitely be equal to 0 because all of these partial derivatives would be derivatives of constants and therefore be equal to 0 themselves. Things that are moving in a straight line tend not to rotate at all, therefore the term irrotational. Now for the next one, we had the divergence of a vector field. Divergence of a vector field is going to be the dot product of an operator, of the del operator, with a vector field f. Now, the reason that this is referred to as divergence, once again, if we think of this in terms of the flow of a fluid, then the divergence of this vector field represents the net rate of change with respect to time of the mass of the fluid flowing from the point per given volume, per unit volume. So this measures the tendency to flow from a given point. Now, to flow from a given point would also be known as to diverge from a point. Therefore, we use the term divergence to measure this. Now, if it happens that the divergence of a vector field is equal to 0, then that means that we tend not to see any flow taking place. F is said to be incompressible. Incompressible. This is due to the fact that if something is not flowing from a given spot, we could neither we would not be able to compress that due to the constant nature of the density of the fluid at that point. Or I guess, long story short, ask your engineering professors. That's probably a better idea than trying to hear me stammer through this.